All right, welcome back to the class. So we are having 4 exponent m is 4 exponent n is equal to 9. Okay, so we can write this as 2 exponent 2, okay, times m minus 2 exponent 2 times n is equal to 9. Can you see that? All right. Now let's introduce a concept of indices here. Okay, now we know that if you're having a, okay, if you're having a exponent m times c, this is the same as a, okay, a exponent m multiplying an exponent of c. All right, now let's apply this concept to our equation. Okay, so you're going to have 2 exponent m squared minus, okay, 2 exponent n squared is equal to 9. Okay, so this is what you have. Okay, all right, so you can see this is clearly difference of two squares. Okay, now here you can choose to represent 2 exponent m and then 2 exponent n by alphabets, okay, and solve them, or you can decide to solve straightforward. Okay, so I want to solve straightforward, so we can say that, okay, a, okay, squared minus b squared, okay, should give us a plus b, a minus b. Okay, all right, so this is the difference of squares identity. Now let's apply this to our question. Okay, so you're going to have 2 exponent m plus 2 exponent n, okay, multiplying 2 exponent m minus 2 exponent n is equal to 9. All right, now here let's look for numbers that can multiply and give us 9. Okay, so we know that 9 can be written as 9 times 1. Okay, 9 can be written as 1 times 9. Okay, 9 can be written as 3 times 3. Okay, now from our question, we can see that the first bracket will be greater than the second bracket, or is the same as what I said, means that 2 exponent m plus 2 exponent n should be greater than 2 exponent m minus, okay, sorry, okay, 2 exponent m, let's clean this. 2 exponent m plus 2 exponent n is greater than 2 exponent m, okay, minus 2 exponent n. Okay, so let me write the m properly. This is m, okay, all right, so this is the first part. Okay, it's greater than the second part, which is this. Okay, all right, now let's continue. Now if that is the case, then we can see that, okay, this will not hold. Okay, since here the result of the first part and the result of the second part are going to be equal, so this will not hold. Okay, this will also not hold. Okay, because we say that the result of the first part, which is this, should be greater than the second part. Okay, so that will also not hold, so we are left with 9 times 1. Okay, all right, so we are going to have 2 exponent m plus 2 exponent n multiplying 2 exponent m minus 2 exponent n is equal to 9 times 1. All right, so we are going to have 2 exponent m, okay, plus 2 exponent n is equal to 9. And we are going to have 2 exponent m minus 2 exponent n is equal to 1. All right, now let's add the equations. So we have this. Okay, let's call this equation 1, call this equation 2. So let's add them. Okay, so you're going to have 2 times 2m. Okay, or you're going to have 2m plus 2m. 2m plus 2m. This will give us 0. It's equal to 9 plus 1 is 10. All right. So this will give us 2 times 2 exponent m is equal to 10. So we divide here by 2, here by 2. So you're going to have 2 exponent m is equal to 2 goes here, 1 goes here, 5. Okay. Now let's apply log. So we can apply log here. Log 2 exponent m is equal to log 5. All right. Now we know from log that if you're having log, okay, a exponent n, the base of b, you're going to have you're going to have n log a base b. Is you're going to have m log 2 is equal to log 5. All right. So to find m, we divide here by log 2. We divide here by log 2. So we have this canceling. Okay. All right. Okay. Now let's introduce another law of logarithm. Okay. So we know that log a over log b is equal to log a base b. Okay. So you're going to have m is equal to, okay, log 5 base 2. Okay. All right. Now we know the value of m. Let's find the value of c. Sorry. Let's find the value of n. Okay. And let's write our equations again. Okay. We know that, okay, 2 exponent m plus 2 exponent n is equal to, okay, let's cross check. Okay. It's equal to 9. Okay. It's equal to 9. Okay, that is equation 1. So we are just calling the previous equations. And then we have 2 exponent m minus 2 exponent n is equal to 1. That is equation 2. Okay. Now, this time, we are not going to add them, but we are going to subtract them. Okay. So that we will be able to eliminate them m. Okay. So you subtract. All right. So you're going to have, so 2 exponent m minus 2 exponent m will give you 0. Okay. So you're going to have 2 exponent n minus 2 exponent n is equal to 9 minus 1. Okay. So this is going to give us 2 exponent n plus 2 exponent n is equal to 9 minus 1 is what? Is 8. All right. So you're going to have, okay, 2 times 2 exponent n is equal to 8. Okay, because we're having 2 exponent n 2 times. So you divide here by 2, divide here by 2. Okay, so you're going to have these two cancel. These two cancel itself 1. Goes here 4. So you're going to have 2 exponent n is equal to 4. All right. So you're going to have 2 exponent n is equal to 4 is the same as 2 times 2. Okay. This has a power of 1. Power of 1. In indices, when the bases are the same and they are multiplying, we add exponents. So 2, 1 plus 1. So you're going to have 2 exponent, okay, n is equal to 2 exponent 2. Hey,